In this lesson, we are going to look at solving problems that involve converting from mass to mole or mole to mass. Now, in this problem, we have how many grams of calcium carbonate are there in 3 moles of calcium carbonate? And notice how we have the unit grams right there, right? And we have the unit mole. And if we look at this problem, this is our given. And how do we know it's given to us? Well, we are starting with 3.5 moles. And if you read this, it's asking for how many grams. So this right here, this is our question mark. And that is what we are going to calculate it for. And to solve this type of problem, we are going to use a conversion factor, 1 or more, that would involve the unit grams and the moles. And that's the reason why we have to memorize those units. And of course, the solving strategy is this. We always start with a given and time as many conversion factors as needed. In this case, we know a conversion factor that allows us to have grams and mole. And we learned that before, and that is the unit of molar mass. Well, what is molar mass? We know that molar mass is a conversion factor, and you noticed somewhere before, we have 1 mole of A is equal to the number of grams of A. And this right here, this is our molar mass. Now, we can solve the molar mass of any substance using the periodic table. And in this case, the compound is calcium carbonate. So in this case, we are going to solve for the molar mass of calcium carbonate. And to abbreviate molar mass, we have a double capitalized M. That is molar mass. Well, I screenshot the periodic table right here that's working with the molar mass calcium carbonate, and I laid out this for you. If we look at the chemical formula of calcium carbonate, it has how many calcium? Well, it has only 1 calcium, and for carbon, it has 1 carbon, and for oxygen, it has 3 oxygen. And that would multiply to the mass of each element on the periodic table. And if we look at calcium, this is the mass of 1 calcium. And then, of course, 1 times 40.08 equal to that. So that's how much mass would the calcium account for in this chemical formula. For carbon, we only have 1 carbon, and that's the same thing. So in this case, carbon is 12.01, and 1 times 12.01 is 12.01. For oxygen, we have 3 oxygen. In this case, 3 times 16 equal to 48.00. And notice we want to keep 2 decimal places because the precision of each element into a mass is 2 decimal places. And therefore, our total mass is, by adding all the masses of all the elements in this chemical formula, and that turned out to be 100.09. And when we express this in terms of our conversion factors, and of course I didn't show right here, but basically if I were to express this as a conversion factor, I'm going to write over here. This would be 1 mole of calcium carbonate equal to 100.09. G, we abbreviate gram with G, and calcium carbonate. And that would be the molar mass right there. And this is our conversion factor. So remember, molar mass is just a conversion factor. So I'm going to abbreviate the conversion factor. Now let's go back to our problem. Well, we know that this conversion factor will allow us to exchange between the unit mole and grams. And to solve this problem, we always use this strategy. Always start from our given. And we have this format laid out for you. So we take our given, which is right here, 3.5. That's our given. And what is that going to do? Well, we are going to multiply to our conversion factor. Now, if we look at our conversion factor, we have 2 sides to the conversion factor. One has the unit mole, and the other one has the unit grams. So if we multiply, the question is, which one go on the bottom? Well, think of this like a fraction. We are multiplying this fraction right here. This is a fraction right here. In this case, that is the unit moles of calcium carbonate. We have to multiply the mole with the moles on the bottom. So we had to cancel out the unit moles of calcium carbonate by dividing it, because x divided by x is equal to 1. In this case, moles of calcium carbonate will cancel out each other. And if the moles of the calcium carbonate is on the bottom, the leftover, which is this side right here, must be on the top. And if we take this and we plug into our calculator, and what we're going to use is we're going to use a Google Calculator. And let me plug this in for you. 3.5, okay? We multiply everything on the top and divide everything on the bottom. And so our answer should be this right here. And our answer should be that one right there. So let's try this one. 3.5 times, notice how the mole is gone, so we don't have to worry about that. But 100.09 grams of calcium carbonate. And divided by 1. Well, anything divided by 1 is the same thing as multiplied by 1. Is equal to itself, and enter. And our answer is 350.315. And we're going to round that. Notice how we're going to round at 2 decimal places, so the 5 will make the 1 into a 2. Therefore, our answer is 350.32 grams of calcium carbonate. And notice how the moles is completely gone. It is now only left with grams. And that is exactly what we are solving for. Grams of calcium carbonate. Now let's look at another example where we are going to use the conversion factors, which is exchange between grams and mole. The same conversion factor, but it is using in a different way. In this case, how many moles of ammonium oxide are there in 23.25 grams of ammonium oxide? Well, going back to the same strategy, given time the conversion factors, and we know that the conversion factor of molar mass will allow us to have mole and gram. So let's go back and read the problem. And of course, we know that we are solving for mole. That would be our question mark. We are looking for it. We are calculating for it. And where are we starting from? We are starting from our given clue, in this case, 23.25 grams of ammonium oxide. So this right here, that is our given. So you should be able to distinguish the given and what we are solving for. Now, going back over here, we have to solve for the molar mass of ammonium oxide using the periodic table, and I laid out the framework for you already. Well, look at the chemical formula for ammonium oxide. We know, and here's the screenshot of the masses of all the elements involved in the chemical formula. For nitrogen, see right there, that 2 right there represent there are 2 of these right here. That means we have NH4 1 and we have NH4 again. That's because of the parenthesis of NH4, and that's a 2 right there, because of that 2 right there. In this case, what we have here is 2 nitrogen because of that 2 right there. And what's the mass for nitrogen? Well, nitrogen is 14.01. See again, 2 decimal places. What about oxygen? Well, oxygen is right here. There is only 1 oxygen, so 16.00. That's oxygen right there. And then for hydrogen, we have 2 times 4. Because 2 of 4, that is going to be 8. So 2 times 4 give us 8 hydrogen total. And the mass of 1 hydrogen is 1.01. And we multiply them, and of course we get these masses right here. And to get the total mass of the entire compound, we add them all together and give us our total mass of 52.10. And again, keep 2 decimal places because our periodic table has 2 decimal places. Now, let's express this in terms of conversion factor. Of course, we always have what? The same format. By definition, molar mass is always equal to 1 mole of A, and that is the substance right here. That's your substance, the chemical formula. And this is always equal to the number of grams of A. Well, A, again, is the substance, ammonium oxide. And I express this in terms of 1 mole of ammonium oxide. And remember, we don't space, equal to the number of grams, which is in this case 52.10 grams of ammonium oxide. Now let's see how we're going to use this molar mass, which is abbreviated by double capitalized M. And let's look at this problem. We're using the same solving strategy. We have our given, which is in this case 23.25 grams of ammonium oxide. We always start with the given, time our conversion factor, and in this case we are lucky we have a conversion factor that has mole and grams. So we just have to multiply by that one conversion factor. And again, notice how this is now grams of ammonium hydroxide. So if we multiply our conversion factors, we have two options, the mole or the grams go on the bottom. And in this case, we want to solve for moles of ammonium hydroxide. So we're going to put the grams on the bottom. And notice we have grams of ammonium hydroxide divided by gram of ammonium hydroxide, just like x divided by x equal to 1. In this case, grams of ammonium hydroxide divided by, in this case, we have grams of ammonium hydroxide, which in this case, NH4,2O divided by grams of NH4,2O. That is also equal to 1. And if the gram is on the bottom, the other side must be on the top because this is a fraction. This conversion factor can be expressed as a fraction. So therefore, the mole go on top. And that is exactly what we are solving for. And to do this, now we just have to multiply them. Everything on top, multiply everything on top and divide every single number on the bottom. In this case, we have 23.25, right? Multiplied by 1, which is equal to itself. And we're going to divide everything on the bottom, divided by 52.10. And what do we have? 0.446. And we want to round to 2 decimal places. So that 4 will become a 5 because that 6 right here make the 4 into a 5. So our answer is 0.45 moles of ammonium hydroxide. And always remember to type that 0 in, okay? So that is how we use molar mass to convert between grams and mole.